Alright, this lesson kind of pulls together all the stuff we've learned regarding integration this semester. And I'm going to start with 3 examples. Now, superficially, they all look very similar, don't they? But they're actually going to give us very different results. Let's look at A. Okay, so notice that I've got an x squared and an a squared. So this is going to be inverse tangent. And the rule for that is the integral of 1 over x squared plus a squared dx is the arc, hang on a minute, 1 over a arctan of x over a plus c. A in this case is 3. What about that 4? We'll just put it in front, okay? So it's going to be 4. Well, I keep forgetting the 1 over 3, don't I? The 1 over a. 4, and then 1/3, because a is 3, arctan of x over 3 plus c. Okay, let's look at B. So B is 4x over x squared plus 9. Since I have this x in the numerator, I can do a u du substitution. I'm going to let u equal the denominator, which means du is 2x dx. So I'm going to put the 4 in front. I'm going to put a 2 inside, which means I'm going to divide by 2 outside. And now I'm ready to do my substitution. So I have 2 integral 1 over u du, which is 2 times the natural log of u. In this case, x squared plus 9 plus c. Okay, and then finally, we've got c. Okay, so what's going on here? Well, since the degree of the numerator is the same as the degree of the denominator, I'm going to do long division. So I have x squared plus 0x plus 9 into 4x squared plus 0x plus 0. Okay, multiply the x squared by 4 to get 4x squared, and then I get 0x, and then I get 36. And when I subtract, I get negative 36, which is my remainder. And so that integral now becomes 4 over x squared plus 9 dx minus, no, wait a minute, my mistake. It becomes the integral of 4 dx minus 36 integral of 1 over x squared plus 9 dx. This is 4x. This is our arctan again. Oh, I almost forgot to do it again, didn't I? Got to do the 1 over a in front, don't I? Okay, so I get 4x minus 12 arctan x over 3 plus c. 3 similar looking problems, 3 very different answers. Alright, so here in a handy little list are all the rules of integration that you should know. These are all the ones we've learned for this semester. So you may want to pause the recording at this point and just take a look at it. And you can refer back to it, make a copy, whatever you need. But this is everything we've learned in terms of integration, all in one easy little spot. This is an example of having to use trig identities to do an integral. Okay, we can't do a u du because we don't know, we wouldn't have the, well, I'll just show you. If I let u equal tangent of 2x, du would be 2 secant squared d2x dx, and you notice there's no secant squared anywhere in there. So that's not going to work. Okay, well, remember that secant squared x minus 1 is tangent squared. That's a Pythagorean identity. It's along with sine squared plus cosine squared equals 1. Alright, so I can replace this tangent squared 2x with a secant squared minus 1. So here we go. The integral of secant squared 2x dx minus the integral of 1 dx. And here I'm going to let u equal 2x. So du is 2 dx. So if I put a 2 in there, I'm going to put a 1/2 in front, and I get 1/2 the integral of secant squared u du minus the integral of 1 dx. And this is 1/2 tangent of u, which is 2x, minus the antiderivative of 1 is x plus c. And that's our answer using Pythagorean identity. Alright, here's another handy list. Just some techniques for doing integration. So you can expand a numerator, you can separate a numerator, you can complete the square to make it fit an arc-trig function. Always remember to divide improper rational functions when the degree of the top is greater than or equal to the numerator. You won't see this one that much. Trig identities are very useful, and multiplying by the conjugate of a denominator also creates a perfect square, which lets you use a Pythagorean identity again. So here's a straightforward differential equation. We're going to separate our variables. So I'm going to get dy equals x over x squared plus 100 dx. Integrate. The antiderivative of 1 dy is y. And here I'm going to do a u du. U is the denominator. Du is the derivative of that. So I put a 2 in there and a 1/2 in front. And I get the integral of 1 over u du, which is the natural log of u plus c. And there's my answer. The natural log of x squared plus 100 plus c. So we've seen lots of those like that. And in this section, you're not going to see anything new. It's just review of everything we've done so far this semester. And this is my last example. This is kind of tricky. Watch what happens. I'm going to let u equal the natural log of sine x, which means du is 1 over sine x times the derivative of sine, which is cosine x. And hey, what is cosine over sine? It's cotangent x dx. And guess what? We have cotangent x dx. So all of that is du, and this is u. So this becomes the integral of u du, which is u squared over 2 plus c, and we get 1/2 the natural log of sine x plus, squared, almost forgot the squared, plus c.